Okay, so here's the idea. We're dealing with sequences. And one of the nice ways of sequences to kind of frame our ideas about them is to think about what is the next number. So hopefully, and feel free to pause if you don't want me to just run through this, if you want to think to yourself, what's the next number going to be in this green sequence? 2, 4, 6, 8, 10. Pause if you wanted to. 12 is the next number. And hopefully you can see that because in each case, what we're doing is we're adding 2. And if you recall, when we are adding the same number every time, right? All of these are 2s, none of them are even slightly different. As long as we're adding the same number every single time, what we do is we call this an arithmetic sequence. Okay, what about the red one? 2, 4, 8, 16, 32. Pause if you want to. The next number is going to be 64. And in this case, instead of adding, we are multiplying by 2 every time. And if you are multiplying and all of the numbers are always the same, then we call this a geometric sequence. Okay, so what about these two? These are kind of strange. 2, 4, 6, 10, 16, 26. And my hint to you, if you're stuck here, is look at these two numbers and think about how they might have helped me get the 6. Look at these two numbers and think about how they might have helped me get the 26. Look at these two numbers and pause if you don't want the answer. The next number is going to be a 42. And really what we're doing is 2 plus 4 is 6. 4 plus 6 is 10. 6 plus 10 is 16. 10 plus 16 is 26, and 16 plus 26 is 42. So we're taking the previous two numbers and we're adding them together to get the next number. And in fact, we're doing the exact same thing down here. The reason that I'm showing you this is that I'm about to teach you something about recursive sequences. And these two are really good examples for when we would want recursive. You're going to only need to know about them for this, but I think that it's helpful to know about this. So 1 plus 1 is 2, 1 plus 2 is 3, 2 plus 3 is 5, 3 plus 5 is 8, 5 plus 8 is 13, 8 plus 13 is 21, and to get our last number here, 13 and 21 is 34. You can, of course, use other kinds of things, but yeah. Okay, moving along. This right here is kind of our goal this week. We want to get to a place where we can kind of see and create examples of and work with all of these 4 things. So the 2 types of sequences we really want to care about are arithmetic and geometric sequences. And then there are 2 formulas that we're going to get into, which are recursive and explicit. So here, what we would have is an arithmetic sequence explicit formula. Here we'd have an arithmetic sequence, but a recursive formula. And then of course we can have explicit geometric and recursive geometric. Eventually we're going to fill these in with actual examples, so I might not fill it in with this text here. But just so you have an idea, this is where we're going this week. Okay, before I can introduce you to recursive sequences, what I need to do is I need to introduce you to 2 different sequences and some notation. Notation is just a fancy word that we use for how we describe the way that we write down math. So this is k sub n. That's how we read this, is we say k sub n. And this refers to the nth number in a sequence. So, for example, one might say k sub 1, and that refers to the first number in a sequence. So think to yourself, maybe pause before you go on. Pause right now. Okay. What's k sub 1? Well, it's 17. This right here is k sub 1. If I asked you what k sub 5 is, hopefully you would tell me that k sub 5 is equal to 3. If I asked you what g sub 2 is, hopefully you would tell me that that is 5.5, because this right here is g sub 2. Okay, hopefully that makes sense. Let me know if you have questions. So k sub 2, second number in sequence, cool. K sub n plus 1 is the next number in a sequence. And think about it like this. If I had k sub 3, and then I said, okay, k sub 3 plus 1. So instead of n, we have 3. So k sub 3 plus 1. Well, that's just equal to k sub 4. So if I say k sub n plus 1, I'm like, oh, you were at k sub 3? Go to the next one. By the same idea, if you had k sub n minus 1, that's like, go to the previous one. So k sub n minus 1, so 3 minus 1, that's equal to k sub 2. So that's just saying, oh, go back one. So you were at k sub 3, go back to the previous one. Okay, we're going to need that all in a second. Okay, so here we have explicit formulas and recursive formulas. Let's start with explicit first. These are actually pretty straightforward, and you've seen them a ton before. So the sequence that this one is going to kick out, and I'm not using an equal sign here because I'm just showing you the sequence, is going to be 4, 9, 14, 19, ... And the way that you could see this is if you thought to yourself, okay, what are my x numbers? What are my 5x minus 1 numbers? So I'm going to plug in just the counting numbers here, the natural numbers, so 1, 2, 3, 4, 5. And what I'm going to think to myself is if I put in 1 here, and by here I mean in this function right here, 5x minus 1. This is an example. If I plug in 1, then I get 5 times 1, which is 5, minus 1, which is 4. So this is equal to 4. Here, I could get 5 times 2 minus 1. 5 times 2 is 10, minus 1 is 9, so my number here would be 9. Over here, we'd have 5 times 3, which is 15, minus 1, and that is 14, and then so on and so on. And what's nice about these explicit formulas is if all of a sudden I said, what's the 94th term? Then you can just plug 5 times 94 minus 1, and you would get that the answer is 469. Okay. Other formulas that we can have, if you guys don't recall these, if I wrote something like 2 to the 4th, that is 1, 2, 3, 4, 2 times 2 times 2 times 2. This is just a reminder, in case you've forgotten. But we could have formulas that look like this, explicit formulas that look like this, where if we have x is 1, 2, 3, 4, 5, and then 2 to the x, we could just replace the x. So 2 to the 1 is 2. 2 squared is 4. 2 to the 3rd power, that's 2 times 2 times 2. That's 8. 2 to the 4th, 2 times 2 times 2 times 2, which is 16. And then 2 to the 5th, which is 32. So our formula, or the sequence that we get out of this, 2 to the x, would give me the sequence 2, 4, 8, 16, 32, ... Cool. Well, let me know if you have questions. Let's move over now to talk about recursive formulas. Oh, and I see that I forgot some stuff here. My bad. This is meant to be a 1. Okay, for a recursive formula, what you need is you need a starting term, and then you need an equation, or a rule. So in this case, I'm telling you a sub 1 is 4. So like our first number in our sequence is 4. This is a sub 1. And now I want to know what's the next one, a sub 2. So what I'm going to say is, well, a sub 2 is going to be equal to, and I'm following this formula right here, a sub 2 minus 1 plus 5. And you'll notice if we have like our n and then a sub n. 1, 2, 3, 4, 5. All I'm doing is I'm plugging in 2 for n. So if I plug this 2 in for n, hey, I know what this is, because a sub 2 minus 1, this is just a sub 1. And I already know that a sub 1 is 4. So this is like 4 plus 5. So the next one is going to be 9. So the first one is 4. So a sub 2 would be 9. If I wanted a sub 3, I would say, well, that's a sub 3 minus 1 plus 5. This is just a sub 2 plus 5. But you know that a sub 2 is equal to 9, right? We put that here, a sub 2. So really what this bit is equal to is this is equal to 9 plus 5, which is 14. So a sub 3 is 14. And hey, we're starting to see this pattern. So the next number is 9 and then 14. And then the next one's going to actually be 19 and 24. And lo and behold, hey, hang on a second. 4, 19, 14, 19, 4, 9, 4, 9, 14, 19. These are actually the same formula. So this is an explicit formula, and this is a recursive formula for the exact same sequence. Okay, come on Wednesday with questions. You have 2 questions, or 4 homework questions to practice. So practice those. They're in the Google Classroom, and then come on Wednesday with questions. See you guys then. Baby Seal says hi.